16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
Toyota, known as the world's largest automobile manufacturer, faces new challenges from the booming electric vehicle industry and emerging competitors. To counter this threat, the mega automobile company has unveiled a groundbreaking new engine designed to revolutionize the automotive landscape and reclaim its dominance in the market. What sets this engine apart? How will it reshape the automobile industry? Join us on this special episode as we unveil Toyota's new engine that will destroy the entire electric vehicle industry. Devastation in the EV industry. Toyota had its best year ever in 2023 for selling cars, with a record-breaking 11.2 million vehicles delivered. However, electric cars didn't play a big part in this success. Out of all those cars, only around 104,000 were electric. That's just about 0.926% of Toyota and Lexus cars sold last year. The company thinks there's still a strong demand for traditional engines. The chairman believes people should have a choice and not feel pressured into buying electric cars. He made this clear during a speech to 200 corporate managers and executives. He mentioned plans for a big engine project, which he had also talked about earlier at the 2024 Tokyo Auto Salon. In a question-and-answer session, Toyota shared his belief that despite advances in technology, electric cars won't make up more than 30% of the market. The rest will still be made up of traditional engines, hybrid cars, and fuel cell electric vehicles. He also thinks that hydrogen-powered engines could be part of the solution in the future, but he didn't mention diesel. He added that they've reached a point where they can announce a new combustion engine project. In 2024, many car makers are mainly focused on revealing plans for new electric vehicles, and some even claim they'll stop making traditional engines in the coming years. He mentioned automakers like Jaguar, Chrysler, Lotus, Aston Martin, Bentley, Buick, Cadillac, Rolls-Royce, Genesis, Maserati, Mini, Opel, Vauxhall, and Volvo, which have committed to going fully electric by the end of the decade. Even Toyota's Lexus brand has promised to stop selling cars with combustion engines by 2035. In Europe, Stellantis plans to sell only EVs by the end of the decade. Mercedes wants to switch entirely to electric in Europe by 2030, as long as market conditions are favorable. Audi, their main competitor, will stop making combustion engine cars by 2032. BMW hasn't set a specific deadline yet. The Volkswagen Core brand aims to produce only EVs in Europe starting in 2033. However, Toyota has a different perspective. They believe that battery electric vehicles can be one of several solutions to achieve carbon neutrality. Akio Toyoda emphasized that the charging infrastructure needs to be ready. He pointed out that around 1 billion people worldwide don't have access to electricity. And since Toyota sells cars in those areas, fully committing to EVs wouldn't work well. That's why they're investing in making engines powered by hydrogen. Over the years, Toyota has proven to be a significant tech leader, and there's no doubt that the new internal combustion engine will be remarkable. What makes this new engine special?
How do hydrogen power engines work? The fundamental efficiency of this technology lies in using water as a fuel. But how does one extract energy from water, a seemingly impossible substance? The answer lies in the molecular structure of water, scientifically represented as H2O, consisting of 2 hydrogen atoms bonded to 1 oxygen atom. To unlock the energy stored within water, hydrogen atoms are separated from oxygen through electrolysis. This process involves using an electric current to split water molecules into hydrogen and oxygen gases. Hydrogen is an excellent fuel choice due to its high energy density. When combusted, hydrogen releases significant energy, comparable to conventional gasoline engines. However, unlike gasoline, hydrogen combustion produces only water vapor as a byproduct, making it environmentally friendly and safe. Even though the concept looks promising as it is, there are areas that could be improved to make these engines more practical. For instance, there is a need to enhance systems for splitting water efficiently, devise safe methods for hydrogen storage, and create engines that can effectively utilize hydrogen. The goal is to eliminate the need for complex electric or hydrogen systems. This simplicity benefits electric car users who often struggle to find charging stations and makes refueling easier compared to hydrogen. Experts are curious and ask questions like, can hydrogen-powered performance match that of traditional gasoline engines? Will the driving experience be enjoyable? What makes this new engine stand out? Hydrogen-powered engines can match the performance of their gasoline counterparts, thanks to hydrogen's unique nature as a fuel. When hydrogen burns, it does so much faster than gasoline, resulting in rapid combustion that enhances engine responsiveness, critical for driving performance. In a traditional internal combustion engine, drivers expect immediate throttle response, a distinctive engine sound, and a sense of power. Hydrogen-powered vehicles from Toyota can replicate these characteristics while using a cleaner fuel source. Drivers of Toyota's hydrogen-powered cars can still enjoy the familiar sensations of driving a conventional vehicle, including the engine sound, which is a crucial part of the driving experience for many. These vehicles also excel in racing scenarios, as demonstrated by Toyota's rigorous testing of hydrogen-powered models, showcasing their reliability and potential for high-performance applications. Hydrogen engines can compete with traditional racing cars in terms of speed, agility, and endurance, delivering comparable horsepower to gasoline engines. Toyota's foray into diesel technology has yielded promising results. By modifying and refining existing engine designs to accommodate hydrogen fuel, Toyota has achieved power outputs that rival or even exceed those of conventional gasoline engines. This achievement not only represents a technical breakthrough, but also underscores hydrogen's potential as a proven alternative for high-performance vehicles. Toyota has successfully merged the dynamics of traditional internal combustion engine vehicles with the use of a clean and sustainable fuel source. This approach by Toyota is bridging the gap between present-day automotive technology and the future, offering vehicles that retain the performance characteristics of conventional ICE vehicles. Whether on the racetrack or for daily commuting, Toyota ensures to deliver the performance, sensation, and enjoyment that drivers expect from traditional cars, while also leading us into a new era of environmental responsibility. In developing these new engines, Toyota considered the numerous fascinating environmental benefits of hydrogen. What could these benefits be? Potential impact on the environment. Toyota's focus on eco-friendly technologies highlights the intriguing proposition of hydrogen-powered internal combustion engines. Questions about how these engines compare environmentally to hybrid electric vehicles and plug-in hybrid electric vehicles, and what sets hydrogen engines apart in terms of environmental impact, are answered by recent explanations of the environmental benefits of hydrogen engines. The key element lies in the emission profile, which differs significantly from that of traditional gasoline engines. Gasoline engines release a substantial amount of carbon dioxide, a greenhouse gas that contributes to global warming. In contrast, Toyota's hydrogen engines produce zero CO2 emissions during operation. The primary emissions from these engines are water vapor, making them an exceptionally clean option when considering greenhouse gas emissions. Achieving such minimal environmental impact is possible due to the unique combustion process of hydrogen engines. When hydrogen fuel is used in engines, it reacts with oxygen from the air to generate energy, with water vapor as the sole byproduct. This clean process contrasts sharply with the combustion of fossil fuels, where carbon in the fuel combines with oxygen to produce CO2. Eliminating CO2 emissions from the tailpipe represents a significant step towards mitigating the environmental impacts of the automotive industry. Hybrid electric vehicles, which combine a gasoline engine with an electric motor, and plug-in hybrid electric vehicles, which can be charged by plugging in to charge their batteries, offer improved fuel efficiency and lower emissions compared to conventional gasoline vehicles. However, they still rely on gasoline and therefore produce CO2 emissions during use, albeit at reduced levels compared to traditional vehicles. In contrast, hydrogen engines offer the promise of true zero-emission driving, provided that the hydrogen fuel is sourced sustainably. Another important consideration is the life cycle emissions of these vehicles. HEVs and PHEVs require batteries that use rare earth elements and involve energy-intensive manufacturing processes, presenting environmental challenges. Hydrogen engines, on the other hand, avoid these issues. Hydrogen fuel production mainly relies on renewable sources like wind or solar power, which can result in a more environmentally friendly life cycle compared to battery manufacturing. The efficiency of a hydrogen combustion engine is similar to that of a traditional combustion engine and can even be slightly higher in some scenarios. This is particularly significant in heavy-duty applications where the power output of hydrogen engines can match that of hydrogen fuel cells. Fuel cells exhibit a high power peak at low loads, but tend to decrease in power at high loads, unlike hydrogen combustion engines, which maintain a high peak load. This makes hydrogen combustion engines more suitable for applications requiring high performance. Technologies like Toyota's hydrogen engine are especially valuable now as the world grapples with the challenges of climate change and dwindling resources. They offer new hope for cleaner and greener transportation without sacrificing performance or practicality. Toyota is also setting a new standard with its approach to carbon neutrality, aiming to eliminate carbon footprints entirely. How can they accomplish this ambitious goal? Zero carbon policy. Another important goal of Toyota is to transition towards a future where it emits no carbon, aiming to achieve this with hydrogen and electric cars. However, the plan must extend beyond just making hydrogen cars for individual consumers. It also involves incorporating hydrogen technology into larger vehicles like trucks and buses. Toyota recognizes that solely focusing on electric cars may not be sufficient due to challenges such as long charging times and the environmental impact of battery production and disposal. To address these challenges, Toyota plans to offer a variety of vehicle types: those with hydrogen fuel cells, plug-in hybrid electric cars, and fully electric cars. This approach allows Toyota to meet the needs of different people and driving situations. Transitioning to zero carbon emissions remains a complex issue, as different regions have varying energy sources and environmental regulations. What works well in one place may not be feasible in another. In areas with abundant renewable energy, electric cars may be the most suitable option. However, in regions where hydrogen can be produced using renewable energy, hydrogen cars may be a better choice. The idea behind offering different types of cars is to empower more people to switch to cleaner energy sources. Despite the promises associated with hydrogen engines, there are still challenges that need to be carefully examined and addressed to avoid complications. Limitations that the hydrogen engine industry faces. One major hurdle is the need for more infrastructure to support hydrogen fueling, which currently lags behind the well-established networks for gasoline and electric vehicle charging. This is because hydrogen requires specialized storage and distribution systems due to its high flammability and low density. Creating a widespread and accessible hydrogen refueling network requires substantial investment and coordination. Safety is another serious concern due to hydrogen's high flammability, making it a potentially risky fuel to handle. Toyota is addressing these concerns through meticulous engineering and strict safety protocols. They are developing large container systems for storing hydrogen fuel and advanced sensor technology to detect leaks or prevent accidents. Ensuring public safety goes beyond establishing rules. It also involves educating people on safe handling practices. This is particularly crucial with hydrogen, which can pose risks if mishandled. It's essential that everyone understands how to store, transport, and use hydrogen safely to minimize accidents and mitigate risks. However, educating everyone about hydrogen safety presents significant challenges. It requires considerable time and resources to develop comprehensive training programs that cover all aspects of hydrogen safety and ensure widespread dissemination of this information. Despite these challenges, if we can overcome the hurdles associated with educating the public about hydrogen safety and ensure widespread awareness of the risks involved, we can fully unleash the potential of this technology while prioritizing public safety. Achieving this will require collaboration among governments, businesses, and educational institutions. Together, we can create a future where hydrogen plays a pivotal role in building a more sustainable transportation system. Toyota has made significant investments in hydrogen fuel cell technology for over 2 decades. They introduced the Mirai, the world's first mass-produced hydrogen fuel cell electric vehicle, in 2014, which has since undergone numerous updates and improvements. The company isn't solely focused on water-powered engines. It's also exploring hybrid and fuel cell technologies, demonstrating its commitment to sustainability. Toyota's new fuel cells. To make fuel cells useful in more ways than just cars, Toyota redesigned their technology into smaller modules. These modules combine all the important parts needed for making power from hydrogen, like the fuel cell stack and components for air and hydrogen supply, cooling, and power control, into one compact package. This package can be easily used for different products and situations. Toyota offers two module shapes, a box and a flat rectangle, to fit into various setups. Each shape comes in two versions, giving either 60 kilowatts or 80 kilowatts of power output. This setup lets us use hydrogen power in lots of new ways. Toyota's fuel cells utilize proton exchange membrane technology. This type of fuel cell converts the chemical energy released from the reaction of hydrogen and oxygen into electrical energy. It is clean, emitting only water. Additionally, with a special Toyota innovation, some of the water created is redirected to the membrane to keep it moist. This feature eliminates the need for a separate humidifier in the Toyota fuel cell module. Since 1992, the company has been improving its fuel cells continuously. Their second-generation fuel cell modules are assembled at TME's R&D Center in Brussels. Starting in January 2022, this facility will operate a pilot assembly line using advanced technologies for high-quality assembly. The decision to assemble in Europe aims to meet growing demand in the region. TME's Fuel Cell Business Group collaborates with entrepreneurs interested in integrating our technology into their applications, offering necessary engineering support. Toyota's new fuel cell module has a broad voltage range from 400 to 750 volts and can easily connect to electrical devices. It includes a built-in fuel cell boost converter that simplifies the development and production of fuel cell products. The modular design enhances convenience. The four available models can be combined to match different output levels and installation spaces. This modular approach eliminates the need for designing individual installations for each component of the fuel cell system, streamlining installation processes. To ensure safety with hydrogen and high voltage, they've implemented various precautions to prevent hydrogen leaks. In the rare event of a leak, it is swiftly detected and stopped. The Toyota module is designed to function in diverse operating conditions, including extreme temperatures, high altitudes, and high vibration environments. Various companies have shown interest in using their fuel cell modules, and Toyota has given them support from experienced engineers to optimize designs for fuel efficiency, longevity, and operating costs. This innovation has led to a world-class output density per unit volume. The maintenance requirements of our new module are simple and infrequent, reducing overall costs from procurement to disposal. The hybrid synergy drive. In the future, cars need to improve their environmental and safety performance while still being enjoyable to drive. Traditionally, to make cars more exciting to drive, manufacturers would increase engine size or use supercharging to boost power and torque. However, this often led to lower fuel efficiency, creating a trade-off between power and environmental friendliness. Toyota introduced the hybrid synergy drive, commonly known as THS, in the Prius to change this dynamic. This system breaks the trade-off between power and fuel efficiency. The goal is to deliver both strong performance and eco-friendliness. THS, a type of hybrid system, has a power split device that divides power into two routes. In one route, power from the gasoline engine goes directly to the wheels. On the other route, the electric route, the engine's power is converted into electricity by a generator to drive an electric motor or charge the battery. This unique setup enables features like engine stopping when idling, running solely on electric power, assisting the motor at any speed and efficient energy regeneration. Importantly, this is achieved without needing a clutch or transmission, thanks to a powerful motor with high torque and output at low speeds. The newly developed hybrid system, THS2, focuses on boosting power and enhancing the efficiency of transmitting motor power, which improves overall vehicle energy management. This advancement led to the creation of the hybrid synergy drive, which significantly enhances power and acceleration while achieving top-notch environmental performance worldwide. THS2 builds upon the original THS to achieve even greater efficiency. The new system uses a high-voltage power circuit between the motor and generator, reducing energy loss during power transmission for optimal energy efficiency. THS2 relies more on the electric motor, shutting off the engine when it's less efficient and solely using electric power. when the engine is most efficient. THS2 operates it at optimal fuel efficiency and generates the right amount of electricity. It also enhances energy regeneration during deceleration and braking, improving overall electricity efficiency to achieve the world's highest fuel efficiency. This new technology aims to meet stringent environmental regulations like ATP-ZEV in California, ultra-low emissions level in Japan, and Euro 4 regulations in Europe. This ensures that emissions are exceptionally clean, setting a global standard for environmental performance. THS2 boosts motor power by 1.5 times compared to its predecessor by increasing the revolutions per minute of the engine, motor, and generator. It uses a high-voltage power circuit and a more powerful battery to deliver increased power. This results in a combination of motor and engine power that offers stronger and smoother performance. How does the THS2 system work? This system coordinates the engine and motor seamlessly, with the motor starting the vehicle and supporting regular driving for better fuel efficiency. During quick acceleration, the high-output motor and engine work together to provide optimal power, improving both efficiency and performance. This represents a significant advancement in a smooth and powerful driving experience. Toyota developed all the major parts of THS2 independently. They redesigned the high-voltage power circuit, motor, generator, and battery from scratch, pushing the hybrid system to new levels. The system includes two types of power sources: a high-efficiency gasoline engine using the Atkinson cycle, known for its high expansion ratio, and a permanent magnet AC synchronous motor with 1.5 times more power output, along with a generator, a high-performance nickel metal hydride battery, and a power control unit. The power control unit manages a high-voltage power circuit that boosts the system's voltage to 500 volts for the motor and generator. It also features an AC-DC inverter to convert between AC and DC currents from the hybrid battery. Another essential part is the power split device, which distributes and combines mechanical forces from the engine, motor, and generator. The power control unit controls these components with precision at high speeds to ensure they work together efficiently. The high-voltage power circuit is a key innovation that enhances the THS2 system. With a newly developed high-voltage power circuit within the power control unit, the voltage supplied to the motor and generator has been raised from 274 volts in THS to up to 500 volts in THS2. This upgrade allows electrical power to be delivered to the motor using a smaller current, leading to improved efficiency. The motor in THS2 builds on Toyota's electric vehicle expertise. The system uses an AC synchronous type motor, which is a high-efficiency DC brushless motor that operates with AC current. This motor features neodymium magnets and a rotor made of stacked electromagnetic steel plates for top performance. Additionally, arranging the permanent magnets in an optimal V-shape enhances drive torque and output. By increasing the power supply voltage and optimizing the magnet arrangement, THS2 reaches 50 kilowatts from 33 kilowatts with the same motor size. This makes it the world leader in output per unit of weight and volume. To control the motor, THS2 introduces a new overmodulation control system for medium-speed range control, complementing existing low- and high-speed control methods. This enhancement improves output in the medium-speed range by up to 30% through refined pulse width modification methods. Similar to the motor, the generator in THS2 is also an AC synchronous type. To provide enough power to the high-output motor, the generator spins at high speeds, boosting its output. Enhancements such as strengthening the rotor have expanded the revolutions per minute range for maximum output from 6,500 to 10,000 revolutions per minute. This higher revolution per minute greatly increases power delivery in the medium speed range, enhancing acceleration at low and medium speeds. Consequently, THS2 achieves an ideal balance between a powerful motor and engine combination. Thanks for watching. See you in the next video.